Hello, welcome back to my channel. So this is the topic today, that is mechanical properties of solid from the class 11 physics. So to understand this chapter, first you need to know about the rigid body. Achha, rigid body means something, the body which does not change its shape and size, everything, right? So but there is no body available practically which is perfectly rigid. So that's why from the rigid body the two things came. One is called elastic body and plastic body. So the elastic body is something when we apply external force on a solid object, then what will happen? The solid object will be expanded, right? So when it will be expanded, now automatically it will regain its shape, right? So automatically it will regain its shape, this property. For example, if I will take this rubber band, this is the actual shape of this rubber band, right? So if we increase it by applying external force, it is what is happening basically, the interatomic molecular attraction is does not allow it to move away from each other, right? So that's why it is the elasticity, actually the concept of elasticity. So the force I am applying on the object, that force name is deformation, the force of deformation or deforming force. The external force that I am applying on the object is known as deforming force. Now when we apply the deforming force on an object, the object has a tendency to come back its original shape and size, or regain its original shape and size. This property of the body is known as elasticity, right? So elastic body means which regain its original shape when we stretch a body, an object and solid, so that it will be regain its shape. That means by restoring force it will regain its shape and size. It will regain its shape and size, right? So when it will regain its shape and size perfectly by restoring force, that is concept is known as the concept of elasticity. Okay, that means elasticity is something when we remove the deforming force, the body will regain its shape and size. That force, that is known as restoring force, and that is the property of this property of the object is known as elasticity. Now what is plastic body means? Plastic body means when we apply force, due to the application of force, it cannot regain its shape, and size. For example, I can take an example of a mud, right, or chewing gum. So if you extend it, it will be only extended up, right? It will not regain its shape again. So this concept is nothing but the concept of plastic body, and this property of object is known as plasticity and elasticity. This is the two things you need to know. Now you are applying a force, that force is external force, which is also known as deforming force. Now that object itself having a tendency, internal force, this is the internal restoring force, the force which is acting internally on the object to regain its shape and size, that is known as restoring force. Now basically the stress, the definition of stress is something that is nothing but the restoring force upon area, that the restoring force per unit area, that is the stress equals to. Now mathematically the restoring force, which is coming, that force which attains the body to come back its original shape, and the deforming force, mathematically they are equal. That's why I will write this is nothing but the applied force upon area. So what is the unit of stress? Unit is nothing but unit of force, that is Newton, right? Unit of area, that is meter square. So that means Newton per meter square. That is the unit of stress. Stress is similar, like you can say force by area, which is similar like pressure. Stress means pressure. That means the applied force upon area is nothing but the stress itself. So what is the dimension of it? So dimension is nothing but the dimension of force, that is m l t to the power minus 2 upon area means meter square, that means L square. 1 L cancel, so it will be m L to the power minus 1 T to the power minus 2. That is the dimension of the stress. When you trying to stretch the rubber band, when it is coming back to its original shape, why? Because it is having the intermolecular attraction does not allow it to extend it, right, to move away from each other. So maybe you are thinking that this rubber band has the higher elasticity because we can easily stretch it, that's why it is a more elastic. No, that's a wrong idea. In physics, basically the object which you have to apply more forces, that object is nothing but having the higher elasticity. For example, if we compare the rubber band with a steel body, the steel has the higher elasticity, means coefficient of elasticity is maximum for steel, not for rubber. Why? Because to extend the steel you have to apply more force. So where you need more force to apply for extension, that is nothing but the high elasticity, right? So in physics, elasticity concept is totally different. Remember that in physics the concept of elasticity is totally different, right? So now this is this is all about the stress. Now here the different types of stress. First of all, the first types is tensile stress. Tensile means when the deforming force is used to increase the length, so automatically a restoring force will be coming into action, right? So this restoring force per unit area, while you are trying to increase the length, while you increases the length, that time उस टाइम में जो restoring force upon area होता है उसको बोलते हैं tensile stress, ठीक है? So the second type is compressive stress. Compressive means when you are trying to decrease the length of an object, and that time the restoring force upon area is known as compressive stress, ठीक है? So tensile means when you are increasing the length, that time restoring force upon area is known as tensile stress. When you are trying to decrease the length, the restoring force acting on the body upon area is known as compressive stress. The third type is hydrostatic stress. Hydrostatic stress, that means when there are a lot of forces are acting from all directions, right? When a lot of force are acting from all directions, for example this is the object and there are a lot of forces are acting from all directions, right? So that उस टाइम पे जो stress acting होता है body में, that stress is known as hydrostatic stress, right? Now the next one, the fourth one is shearing stress. The shearing or tangential stress. Tangential stress, what is that stress is? इसमें क्या होता है, एक बॉक्स मान लो, दिस इज द बॉक्स, राइट, whose lower point is fixed. So the lower point is basically a fixed point. Now you are applying force on the top point. So what will happen? As the lower point is fixed, lower point cannot move, so only upper point has been shifted to a new location. Okay, so that means this will create a certain angular shift, this theta, this angular shift, that is known as tangential stress or the shearing stress, right? So that means shearings, there are 4 types of stress. Next topic is strain. What is the strain means? When you are applying some external force on an object, that force is known as deforming force. Now when you are applying deforming force on the object, then object will change its shape, size. Okay, for example its dimension will change, right? Dimension means its length, breadth, height, area, angle. So many things can be changed by applying force externally. So that means strain is nothing but can be defined as it is the ratio of change in dimension upon original dimension. What does it mean? Original dimension. So change in dimension upon original dimension. There are basically 3 types of strain are there. One is called longitudinal strain. Longitudinal strain. Longitudinal strain is something that change in length, when the length has been changed, in that case this concept arises, longitudinal strain. So change in length upon original length, okay. So change in length, if I consider as a delta L upon original length is L. For example, if we take our wire having initial length was L, small l, due to the application of force, external force, let the wire has been extended up to a small extension, that is delta L. So this ratio, the increased length upon original length, is nothing but the strain. Okay? So that is nothing but, it is the length upon length, so it is a unitless and dimensionless quantity. It is a unitless and dimensionless quantity. Okay? So this is the first case, longitudinal strains. Next, volumetric strain. In case of longitudinal strain, it is the change in length upon original length. Now volumetric strain is nothing but change in volume upon original volume. Change in volume upon original volume. Okay, so delta V upon V, delta V upon V. So this is also does not have any unit, because volume upon volume, volume means meter cube, this volume is also meter cube, meter cube upon meter cube can cancel. So there is no unit, no dimension of strain. Okay. So the third point is shearing strain. Shearing strain or longitudinal strain. What does it mean? First let me show you, as I said already, that this is the body whose the lower point is totally fixed. This is the fixed, cannot move. Only the upper surface can move. So if we apply some force on it, so what will happen? This, let example ABCD was the object. As you are applying force on A, the A will be shifting at point A dash. So definitely as A is shifting, so D will also shift over here at point D dash, right? So that means this is the kind of shift happen. This is the kind of shift happen. That means there is a angular shift happen. So here shearing strain is nothing but tan theta. How much angular shift happen? So this is the L, if I consider, and this is the delta L. Okay? So tan theta means, we know for a, this is a right angle triangle, AB A dash is a right angle triangle. So in this right angle triangle, tan theta is perpendicular upon base. Perpendicular means A dash upon AB. A dash is delta L by L. So that means this ratio, the shift, okay, or the displacement of the two layers upon the parallel distance between the two layers, this ratio is known as shearing strain. Okay, so this is the three types of strain. Chalo, next topic is elastic limit. So stress means force by area, or restoring force by area, or you can say applied force by area. Strain means change in dimension by original dimension, has no unit, no dimension, right? So next is elastic limit. As I said already, that when we are applying force on an object, till some extent it will be bounced back. Okay, its original shape will be regained. Again, if we increase, again it will regain. That means by applying stress, the strain is happening, right? There is a change in dimension happens. So stress and strain are related, right? So but this relation takes place up to a maximum limit. So the maximum stress up to which is the maximum stress up to which the body will regain its shape. The body will regain its shape after removal of applied force. Regain its shape, okay, after removal of applied force. So I have applied force on the object, and you know, due to the application of force, its shape changes. Okay, बट ये शेप चेंज एक मैक्सिमम लिमिट तक होगा, उसके बाद जाओगे तो ये टूट जाएगा, ठीक है। सो दैट इज द कॉन्सेप्ट, द मैक्सिमम स्ट्रेस दैट कैन बी अप्लाइड on the body up to which it will regain its back, its comeback, it turn back to its original shape, okay, it bounce back to its original shape after removal of the deforming force। तो deforming force जब मैं छोड़ दूंगा तो वो वापस आ जाएगा। कहाँ तक वापस आएगा? वो मैक्सिमम स्ट्रेस कब तक है? जब तक वो वापस आ सकता है अपने आप। दैट मैक्सिमम लिमिट इज नोन एज द इलास्टिक लिमिट, ठीक है। So up to elastic limit, stress or strain interrelated. Remember that up to elastic limit, the stress and strain are interrelated, and that is defined by Robert Hooke, by Hooke's law. So according to Hooke's law, within elastic limit, the applied stress is directly proportional to the strain, ठीक है। So within elastic limit, stress is directly proportional to strain. Up to elastic limit, the stress is directly proportional to strain. So stress proportional to strain. So to remove that proportional sign को हटाने के लिए एक कांस्टेंट आता है, इस कांस्टेंट का नेम होगा the coefficient of elasticity or modulus of elasticity. That means this constant into strain. So this constant term is nothing but stress upon strain, which is also known as modulus of elasticity, or it is also called coefficient of elasticity, okay। So this constant is stress upon strain. This ratio, stress by strain ratio, is always constant. It is only material properties. Remember, it is only material property. If you do not change the material, it will be remain constant. If you do not change the material, remember that, ठीक है। So constant, that means stress upon strain. So modulus of elasticity is three types. One is Young's modulus, second is bulk modulus, and the third one is modulus of rigidity or shear modulus, okay। So this is the symbol. So there are three types of modulus of elasticity: Young's modulus, bulk modulus, and modulus of rigidity. So now what is the unit of modulus of elasticity? So unit of modulus of elasticity. So modulus of elasticity, this constant name is modulus of elasticity, that is nothing but stress upon strain. So unit of stress, that is Newton per meter square. Strain does not have any unit, okay। So the unit is Newton per meter square. Ultimate unit is Newton per meter square. So what is the dimension? It is the same dimension of stress only. So the dimension is m l to the power -1 t to the power -2, the dimension of stress only, okay। So this is the unit and dimension of modulus of elasticity.